Hello everyone, my name is Benjamin Gazeau from Curtin University in Western Australia, and I'll be discussing innovative solutions for fishing gear waste today. So the focus of the research project is to identify substitution materials, and if no substitution can be found, then we're going to talk about alternative material. In order to replace conventional plastics currently used in the fishing industry, which are mainly fossil-based material. So to distinguish between substitution and alternative, we decided to use the definition from the United Nations. And so to summarize that definition, it states that substitution material cannot be plastic material, which include bioplastic. The alternative material can include biodegradable plastic. So this project is part of a wider application scope, which includes food, export, packaging, and agricultural mulch. But today we'll only discuss the fishing section, and we will cover the innovative development of materials for this specific industry. The case study for this particular industry will be small island developing states, and specifically the Fijis. Some context to start with: very few studies accounting for tracking marine pollution, and more specifically from lost fishing gear. The most recent analysis revealed that 2% of fishing gear is lost annually. And another important fact is that there are no defined responsibilities for that waste. Basically, upstream stakeholder on the supply chain for the fishing gear, like the material suppliers, the gear manufacturers, benefit economically by trading the equipment or the material, while the downstream stakeholders suffer economic costs with waste management and biodiversity degradation, and so on. Another interesting fact is that the lifespan of fishing gear is estimated between 30 to 35 months. After that, the material is considered waste. But what happens to the waste in waste management needs to be monitored. And is it landfilled? Is it recycled? There is no proper data collection, so there is a gap here. As we already said, the proportion of fishing gear which is lost at sea, intentionally or not, develop post-catch during its lifespan. And just to balance that, the lifespan of conventional plastics of fossil fuel, like the nylon, polyamide, or HDP, PP, and so on, can take up to 2,500 years to degrade. So you can understand how impactful it is for the environment to accelerate that degradation for the gear as soon as possible when it's lost. And so that's why working on innovative materials such as biodegradable plastics or finding natural fibers application would speed up the degradation level, reduce the ghost catching effect, and overall improve the biodiversity by reducing that pollution. So we decided to have a distinction between fishing lines and nets and the fishing traps, because of the substitution and alternative distinction we discussed earlier. Only alternative materials can be used for fishing line and fishing nets. So to summarize, the catch efficiency is slightly under the efficiency of petrol-based material, but the degradation rate of the bioblend material prevails. New blends should still be developed to improve the efficiency of the bioblends in many ways, but there are opportunities to find alternatives. As for the trap application, bioblend or natural fibers can replace conventional material with improved marine degradation properties. And the development of other natural fiber sources is also an opportunity that needs further investigation, because not all the countries have access to the entire range of natural fiber, and exploring local natural fiber would be easier to source and create local economic development as well. As for cotton, depending on the waste management system in the targeted countries, but it is a material that can be sourced from textile waste, but require the development of collection, sorting, and recycling system. So when using the 6R hierarchy, material innovation is considered as redesigning the product, which has positive impacts, as it is shown on the table here. On the table, but policy implementation, such as GPS tracking, coloring, and more, can also help reduce pollution. So you can see here some of the areas that is being developed, like Canada is more, or North America is more looking at regulation system, while other countries or companies are developing more innovative material. To summarize what we've been discussing, innovative material development cannot be the only action to follow if the target is to reduce marine pollution. Policy implementation is also a significant part, but the challenge is that it needs to be a global adoption rather than local. The development of new material needs to continue and to be supported by public and private entities with an aim for international partnership, because some countries might not be able to access the material or being able to manufacture the gear. So that's why international partnership is a key element for the success. So we want to thank all contributors to the project, and here's the different one on the slide. And I want to thank you for listening to me. I'll just move that here. And if you have any question, feel free to send me an email. Thank you.